So that would be practice test number 2. Okay, various equation, linear and nonlinear equation of a second order. The first one is solving the differential equation using the undetermined coefficient. So the first one, we want to solve these equations. Okay, solve each equation. Okay, by the method is given to you, so you have to go with the given method. Okay, and determine coefficient. Coefficient method. So this means you have to find the YP and you have to solve it completely. Okay, that's the one. So the first one, we give you one of them, of course, is a y double prime plus 4y equal to the 3 sine x. You know that it's homogeneous differential equation. You have to solve the homogeneous one first, find the YC. Then you want to find the YP. R of x is a trigonometric function, so undetermined coefficient methods is possible. Okay, so this is how we're going to solve it. So we're going to solve this one first, y double prime plus 4y equal to 0. You get the characteristic equation, which is going to be r squared plus 4 equal to 0. So r squared equal to the negative 4. So r squared would be 4i squared. So r is positive negative 2i. So we have complex solutions, complex roots. You take one of them, r equal to the 2i, which is the same as 0 plus 2i. So this is going to be your alpha plus beta I. So you get the alpha equal to the 0 and the beta equal to 2. So your solution is going to be trigonometric one. Okay, so YC is going to be equal to the C1 e to the 0 cosine of e to the alpha x. Remember cosine of the beta x. Cosine of the 2x plus C2 e to the 0 sine of the 2x. So we put them together. So YC is C1 cosine of the 2x plus C2 sine of the 2x. So this would be solution to the homogeneous part. Straightforward one, nothing to worry about. Now we have to find the YP. The method is given to you, so you want to find the YP. Rx, okay, the other side is 3 sine x. Remember, we are going to focus on the coefficient and change it to a polynomial with undetermined coefficient. The coefficient is a constant. For the sine, you have a combination of sine and cosine. It doesn't matter whether you have a sine or cosine or whether you have both of them together. So in this case, the suggestion for YP is going to be equal to a constant like A1 times sine x and a constant like A2 times cosine x. Then you check to see if there is any duplicated term between the YP and the YC. In this case, there is none, because you have a cosine of 2x, but this is sine and a cosine of x. So checking is completed, and you go for it. Yes?
On the exam, would you mark this down if we were using like A and B?
It doesn't matter. You can use whatever notation you like. Okay, so the checking is completed. So we are going to use the YP. There is no duplicated terms. If there's going to be one, you know that you're going to upgrade it by multiplying by x squared, etc., to remove that duplication. Now the checking is completed, so you have to find the y double prime, go back, substitute, and find the I1. Okay, so go with the y prime. Y prime would be A1 cosine of x plus A2. The derivative of a cosine is negative, so it's going to be negative A2 sine x. That's a negative. Okay, that's a y prime. You take a y double prime. y double prime is going to be negative a1 sine x. Lift of a sine is cosine minus a2 cosine x. Okay, we are going to take these two into the original equation. So original equation is y double prime plus 4y equal to the 3 sine x. Now we substitute. We have the y double prime. It's a negative a1 sine x, okay, minus a2 cosine x plus 4y. It's going to be 4 times y. So the y is just at the yp. So going to be 4 times a1 sine x plus a2 cosine x. And this is equal to 3 sine. Okay. Now you simplify and then you get the coefficient of the similar terms to be equal to each other. So this is it. It's a negative a1 sine x minus a2 cosine x. Distribute the 4. So 4a1 sine x plus 4a2 cosine x. And this is equal to the 3 sine x. Combine the like terms. So this is the negative a sine. See, this is 1 sine and this is 4. So that gives you 3. Okay, 3a1 sine x. And in the case of the cosine, the same thing. It's going to be plus. Okay, that's it. Plus 3a2 cosine x, which is equal to the 3 sine x. You might think about this one as 3 sine x plus 0 cosine x. And you let the coefficient to be equal to each other. Okay, the coefficient of the sine is 3a1, and over here is 3. The coefficient of the cosine is 3a2, and here is 0. You compare them together, so we get 3a1 is equal to 3. This is from the first one. So that gives you a1 equal to 1. And the second one, 3a2 equal to the 0. So that gives you a2 equal to the 0. So the final answer for the yp. So the yp is going to be a1, which is 1 times sine x plus a2 cosine, which is 0 cosine. So it's going to be sine x. Okay, so yp is equal to the sine x. So the solution of the equation, you know that y equal to the yc plus yp. That would be fine. If you want to repeat it, it's going to be c1 cosine of the 2x. Except that, of course, if you write c2 sine of the 2x plus sine x. So that would be the solution to this equation. Okay, straightforward. Like the one that we gave you on the quiz, we give you one of them. That's you must make sure that if there's going to be a duplicated term, upgrading that term. And you will see it. If you miss it, you cannot find this A1, A2, A2. Then the only place that you make a mistake is to, yes.
So the only place you look for duplicated terms is in
YC, YC, YC. You cannot have, you cannot have shading between these two. Okay, so this was the part 1. Any question? We do part 2 because it maybe have that duplication that we're going to be interested in. Okay, so we give you one. It's either with the trigonometric function because we have 3 choices: exponential function, polynomials, and the trigonometric function. I think the one that we got on the quiz was exponential one. So this is part 2 of the same problem. Okay, that's part B. Part B, the equation that you have to solve is this one: y double prime plus 10y prime. Okay, y double prime plus 10y prime plus 25y, which is equal to the 14. e to the negative 5x. You take this one, your yp is exponential function. The coefficient is constant, then you change it to the constant, of course, depends on the, you get the repetition or not, of duplication. Okay, are you ready? Going for the homogeneous first. Solution. So the homogeneous one is y double prime, 10y prime, plus 25y equal to the 0. That's homogeneous one. Get the characteristic equation, which is r squared plus 10r plus 25 equal to the 0. You factor it, you have a 25 over here, so you get the repetition. Repeated solution is going to be r plus 5 squared, or r plus 5 equal to the 0. 5 squared 25, twice of the first time second, that's 10. Okay, so we get r equal to the negative 5 and negative 5. It's a repeated solution. When we get the repeated solution for the first one, so yc is equal to, it's going to be c1 e to the negative 5x for the first one. And since it's repeated, you multiply by x. So it's going to be plus c2x e to the negative 5x. So that would be the solution to the homogeneous. Any question? Now the yp. You want to find the yp? So you look at r of x. So what is rx? Rx is 14 e to the negative 5x. So 14 is a number. So your yp would be a number, constant polynomial like a1 e to the negative 5x. So you check to see if it is all right. But as you can see, e to the negative 5x and e to the negative 5x are here. So it's not going to be a good one. So you change it to the a1 e to the negative 5x multiplied by x. And you check again, x e to the 5x is also here. So you have to multiply it by another x. So make it to the x squared. So the yp that we have to use is going to be a1 x squared e to the negative 5x. So this is going to be a yp. Any question? So we must make sure that you don't miss this part. Now you have to differentiate it. Okay, differentiate it to y prime, substitute, and eventually get your a1. Okay, start differentiate it. Y prime. You got to be careful because we have to use the product rule because of the x squared here. So derivative of the first time second, first. Derivative of the first one will be 2x, which is 2a1 x e to the negative 5x. Okay, plus the derivative of the second first. The second one e to the negative 5x would be negative 5. So it's going to be minus 5 a1 x squared e to the negative 5x. That's the derivative of the second times first. Okay, derivative of the second one, negative 5 times exponential function. So this is y prime. Now we differentiate again to get the y double prime carefully. So what's going to be y double prime? For the first one, again, we have to use the product rule. Okay, the derivative of the first time second, that give you 2. So 2a1 e to the negative 5x. That's the derivative of the first time second. Then second first, that give you negative 5 here. So negative 5 times 2 would be negative 10. So minus 10 a1 x e to the negative 5x. Okay, so just apply the product rule to get this part. Now we continue get it to the second one, same thing. Derivative of x squared is 2x, 2 times 5 would be 10. So it's going minus 10 a1 x e to the negative 5x. Plus the derivative of the second times first. We get the negative 5 again. Negative 5 times negative 5 would be positive 25. a1 x squared e to the negative 5x. Okay, so that gives you the second derivative. You check to see if you can simplify it before going to the next part. So we have a 2a1 e to the we can simplify the middle one only. See, this middle one are the like terms. So it's going to be y double prime equal to the 2a1 e to the negative 5x, 10a1, and the 10a1 would be 20 a1x e to the negative 5x, and then you have a 25 a1 x squared e to the negative 5x. Okay, so that would be your yp double prime. So go back, substitute the original equation. We have the yp, y prime, and just to write the original equation again. So this is where we are going to substitute y double prime, 10y prime, 25y equal to the 14 e to the negative 5x. So bring them down here. Y double prime, this is your y double prime. So it's going to be 2a1 e to the negative 5x minus 20a1 x e to the negative 5x, and the plus 25 a1 x squared e to the negative 5x. This is all for y double prime. It's y double prime. Okay, plus 10y prime plus 10 y prime. We multiply the y prime. This is the y prime. So it's going to be 2a1 a1x e to the negative 5x minus 5 a1 x squared e to the negative 5x. This is 10 a, okay, 10y prime plus 25y. So it's going to be plus 25y, 25 a1 x squared e to the negative 5x. All of them equal to 14 e to the negative 5x. That's it. It would be simplified quickly. Then you drop e to the negative 5x, and then you get the job. Okay, but you have to multiply the 10 inside and do the simplification. So this is how we continue. We get the 2a1 e to the negative 5x and the minus 20. Have to repeat it. a1x, negative 5x, and this is plus 25 a1 x squared e to the negative 5x. Now start multiplying the 10 inside. So that give you plus, okay, plus 20 a1x e to the negative 5x minus 50 a1 x squared e to the negative 5x. Okay, and plus 25 a1 x squared e to the negative 5x. And this is equal to the 14 e to the negative 5x. Those come with the x and x squared should cancel out. All of them, okay? So we start with the x here. This is a negative 20 a1, and this is a positive 21 a1. So these two will cancel out. Then go for the x squared, 25 a1 x squared, and the 25 would be 50, and the 50 will cancel out. All of them should disappear unless you made a mistake. So the leftover is easy term, 2a1 e to the negative 5x from one side, and the 14 e to the negative 5x from the other side. Coefficients the same. So that gives you 2a1 equal to the 14. So a1 would be 7. That's it. So your yp is a1, 7 x squared e to the negative 5x. So this is going to be your yp. And the final answer, we know that. Y equal to yc plus yp. And you already got 4 of them. So that gives you the final answer. Okay, so it's nicely done. Unless you misassign something, it should all disappear to give these numbers. So we give you something that you'll be able to do it quickly because it takes time. Okay, that's a question number one, or the topic number one. That's going to be given to one question from number one. Okay, any question? Number two, that's a review. Yes. Which section? Undetermined coefficient. I think it's 4.5 or 4.6 or something. Okay, that's one. I just checked the recording that we have. Some of them seems to be a good one. We missed a couple of the first one because of there was no good sounds. So I post them on the YouTube. So I will give you a link on the on the canvas. You can watch them. Okay, and you already got the lecture notes. The leftover, I will post all of them again. So you can compare them together in case you miss anything. Okay. So there are lots of noise, your noise. So just check it. If there is something that you don't like it, then there is nothing from your information. In case there was something you don't like it, let me know. And I can delete it. Okay, that's it. Yes.
And now we're doing homework through chapter 5.1, was it? For the power series, that's the last homework section.
I should check that one. Yeah, okay. Then I let you know. And finish this one. Okay. So we may give you more time, to do your assignment. So that's the topic number one. Okay. Only the topics on the review. This is the way you study this. Okay. If you don't see anything over here, means it's not complete. So that's topic number one. Topic number two, we would like to check the homogeneous equation of the higher degrees or the higher order. The way we are going to do it, we are going to give you that one, but we don't want you to give us a complete solution. So we ask for the form of the YP only. Okay. So that's the topics of the second one, because you have to solve the homogeneous equation, of course, to get it. And that is the purpose of the question number two. Okay, question number two. An equation would be given to you. It's a non-homogeneous. I would like you to just express the YP for us. Okay, express the YP. So that's a number two, or the topic number two. That's it. We find a suitable. Okay, find a suitable. That's it. Form for YP of X. Okay, YP of X, of course, if we use, if the undetermined method is used, if the undetermined coefficient coefficients is to be used. So we don't want you to calculate the coefficients because it's not possible for you. It takes time. Let's give us the YP. Okay, the equations are going to be higher order, not the second order, because we want to check the solution of homogeneous one. Okay, part one is the y tiers minus y prime, and this is 2 cosine of t. Okay, plus t e to the negative t. Okay, so in this case, R of X are two types of function. The trigonometric one and exponential one. We do it separately, but we put them together. But we have to solve the homogeneous one first, because you need the YC to make sure that there is no duplicated term. Okay, so for the solution, we'll solve the homogeneous one first. Okay, change it to the characteristic equation. So R cubed minus R prime minus R equal to the 0. So you have to solve this equation. How are we going to solve it? R cubed minus R equal to 0. Right. Factoring. Okay, we factor the R. So factor R, that gives R squared minus 1 equal to the 0. So we get R equal to the 0, negative 1, and positive 1. So we have three solutions. There is no repetition. So the YC is going to be C1 e to the 0 plus It's a t, we go with the t, okay, c2 e to the negative t, and the c3 e to the positive t. So your yc is a constant, and a c2 e to the negative t, and the c3 e to the t. So this is yc. Okay, any question? Now bring the r of x and compare them together. So we'd like to find the yp. So we have two types of function. Okay, we have a true cosine t plus t e to the negative t. We write each one of them separately, but we add them together. So what's going to be the yp for the first one? The first one is a cosine function. Okay, so we need a combination of cosine and sine. Since the coordinate, the coefficient is just a constant, so this is going to be a constant polynomial. So you may start with the a1 cosine of t plus a2 sine of t. You check to see any duplication? No. You see this your yc, nothing to do with this, okay, with this term. So we are done with the first function. Any question? Second function is the coefficient is t, so polynomial of the first degree. So you have to introduce a polynomial of the first degree, and that would be, so it's a plus. So we have a1 and a2, it's going to be something like a3. You can use any other letter you like. a3 plus a4t, okay, times it by e to the negative t. Then you check to see if it's going to be here. You see, you multiply inside to see a constant times e to the negative t. A constant times e to the negative t. So it's here, so you have to upgrade it if you like. You multiply by x, then you check it again. You see, you don't have any, sorry, this is t. It doesn't matter, they go with the t. So you have, you multiply by t, and as you can see, there is no duplication anymore. So that's it, it's done. Okay, so the yp is a1 cosine t plus a2 sine t, and it's a3 plus a4t times e to the negative 2 times t. You can bring the t and multiply it inside. It's not optional. But they ask for the yp, so we are done. We get the yp. Any question? So the purpose is solving the homogeneous, okay, equation of the higher order. We are not going to give a separate question like the quiz. So they are here. So it covered it once. Okay, that's part one. Any question? So that's the first one. We have the check the other one. Part B. Part B, your equation is y to the fourth. Okay, fourth order. And the 4 y double prime. Then you have t e to the t. Okay, plus 4 plus sine of 2t. You have a kind of three functions. Okay, the first one is the exponential function, the second one is a constant function, and the last one you have a sine. So okay, so solve the homogeneous one first to see what's going on, and then we come back and we take care of it. Okay, there you are. Homogeneous one. y4 to the fourth order, 4y double prime. Homogeneous characteristic equation, r to the fourth plus 4r squared. Okay, equal to the 0. Again, you factor out the r squared. Okay, to continue. So it's going to be r squared times r squared plus 4 equal to the 0. Okay, so far we get from the r squared, we get 0, 0. And from here, r squared, if I write it down, r squared equal to the 0. That give you 0, 0. Okay, and then r squared plus 4 equal to the 0. So that make it to the r squared equal to the negative 4, which is going to be 4i squared. So r would be positive negative r. So you have one repeated real solution and the complex. Okay. So take care of the complex. It's R equal to the 2i. Think about it, 0 plus 2i. So alpha 0, beta 2. Now write the equation. So what's going to be your YC? YC is equal to R is 0, 0. So for the first 0, that give you C1 e to the 0. That's the first one, but then it's repeated. So it's going to be C2 T e to the 0. Okay, the repetition one. Then we get to the complex. So for the complex, we get the C3 e to the 0 cosine of 2t plus C4 e to the 0 sine of the 2t. If you're comfortable writing down those e to the 0 right away, we don't mind. So the final answer is this one. YC is equal to, we get the C1, okay, plus e to the 0 is 1. C2t plus C3 cosine of the 2t plus C4 sine of the 2t. So this is going to be your YC. Any question? You see, 0 was a repeated solution. R equal to the, we got the R square equal to the 0, so you have two solutions, 0, 0. So the first one would be e to the 0, the second one would be t e to the 0.
If you deduct points if I put an X instead of P on the test.
Yes. No. But you know, I just put a question mark. What do you mean? Which one is it? Is it X or T? Okay, that's one.
What if we make our own variable? Would you be upset?
No, in that case, we give you 0. Yeah, once I had a student said, "Hey, professor, you made a mistake. The power must be 3." I said, "No, it's not. The power is 4." He said, "But I would like to solve it with the power to be 3." I said, "Okay, do it," and I don't give a point. Okay, so let's see what would be the YP now. Now bring R of X. So we want to find the YP. Okay, now what is R of X? You have 3 types of function. Okay, exponential one, a constant function, and the sine function. Carefully, you have to write 3 different YPs. Okay, are you ready? The first one. The first one, we would like to take care of this. T is a first degree, okay, linear polynomial, so we need a linear polynomial. So the linear polynomial would be what? Would be A1 plus A2t times e to the t. Okay, so we check to see if it's going to be enough. If you check with this, the YC, there is no duplication for this one. So we are going to be fine so far. Yes.
If it was T squared, E to the T, would there be
Then-
3 terms?
Then you have to get the quadratic.
Okay.
It's going to be A1, A2t plus A3t squared.
Okay.
It must be a complete one. Okay, that's it. Yes.
Oh, never mind. The A1 and A2 T are multiplied by the E to the T.
That's it. Yeah, yeah. It's not going to be here. Yeah, when you want to consider it, you have to consider it there. Okay, all the time. Okay, so we are done with first one. No repetition. We go to the second one. The second one is a constant. So we bring a constant polynomial. I go with the A3. In this case, A3. But we check to see if it's going to be enough. We have a constant here. So it's not enough. So we have to multiply by T, A3T. You have a constant times T here. So you have to raise it again. So that would be T squared. Okay, we need a t squared because we have a constant over here and we have a constant times t. So we have to make it, so that we don't have any duplication. Any question? So that is the second function. The third function is the sine function. You know that for the sine, you have to get a combination of sine and the cosine. So the combination of sine and the cosine for this one would be what? The coefficient is 1, a constant polynomial. So it's going to be a4 sine of the 2t plus a5 cosine of the 2t. Remember, always you have to have the sine and the cosine together. Then you check to see if it's enough. You see the duplication is here. So we have a cosine of the 2t and the sine of the 2t. So we have to multiply all of them by t. So this is going to be the final answer. Okay, so we have to be careful for each part to see if there is any need, you raise it, you get the t here. Any question? Of course, you are not going to find these coefficients. It's possible, but
Would we get extra credit if we were able to solve for them somehow?
this one, you will lose the test because it takes you 20 minutes to find it.
Doesn't matter if it's sound.
It doesn't matter. Yeah, it's a sine and cosine. You can use either one. It's important to have if there is any repetition, otherwise no. Okay, so that was a good one. The equation was good. Okay, the repeated solution that we have. That's a part B. Any question? We have another one. This is the third one. So we give you one of these. It's repetition one. So that's going to be part C. The part C, let's see what's the equation that we have over here. Is y is the fourth order plus 2 y of the y tiers. Okay, and 2 y double prime. That's the function, that's the equation, is equal to 3e to the t, okay, plus 2t to the negative t. And then we have e to the negative t sine t. Again, a combination of three functions, okay? So check the homogeneous one to see what's going to be yc, then you come back and you take care of it. Okay, so solution, homogeneous one. Okay, so for the homogeneous one, it's y to the 4. Okay, plus 2y tiers and the 2y double prime equal to the 0. Okay, so that gives you the result. Okay. That's it. Okay. So the characteristic equation would be r to the 4th plus 2r to the 3rd plus 2r squared equal to the 6. You want to solve this equation? How can you solve it? Pull out, yes, pull out r squared as a factor. So that gives r squared. So the left out is going to be r squared plus 2r plus 2 equal to the 0. From the r squared equal to 0, you get the repeated solution. R squared equal to the 0. So that gives you r equal to the 0, 0. Repeated solution. Now the leftover would be r squared plus 2r plus 2 equal to the 0. You have to solve this equation. You cannot factor in. You have to go with the quadratic formula. It's probably you end up with the complex solutions. Okay, so let's do it. R is equal to negative b negative 2 plus or minus the square root of 2 squared minus 4 times 1 times 2 divided by 2 times 1. Okay, so it's going to be equal to, you get the negative 2 plus or minus 2 squared would be 4 minus 8 divided by 2 4 minus 8, that give me -4, which is going to be good. Okay, -2 plus or minus -4 over 2. -4 would be 4i squared, that give me 2i. So r is equal to the -2 plus or minus 2i divided by 2. You break it to get the complex format, -2 over 2 plus or minus 2 over 2i. You simplify the 2, so -1 plus or minus I are going to be the complex solutions. Okay, you take one of them, you identify the alpha and the beta. So we take the r equal to -1 plus I equal to the alpha plus beta I. So the alpha would be -1 and the beta would be +1. Okay, now the solutions are going to be, remember we have 0, 0. So what's going to be YC? YC is equal to the C1 e to the 0, the first solution, plus C2 t e to the 0 because of the repeated solution. Then the complex, it's going to be C3 e to the -t because of the alpha, cosine of beta t, which is just t because the beta is 1, plus C4 e to the -t sine of t. Okay, so e to the 0 would be 1, so the YC is this one. YC is C1, C2t, C3 e to the -t cosine of t, plus C4 e to the -t sine t. So that would be the YC, the homogeneous one. Any question? So they know the target is going to be just solving this type of equation for us. Now bring the R of X and check the YP. Okay, so there you are. What is going to be YP? R of X is this one. You have 3e to the t plus 2t e to the -t plus e to the -t sine t. This is what you have, 3 types of function. Again, exponential function, true exponential function, and the trigonometric one. Okay, so what is going to be now RP? We take care of the first function first, e to the t. The coefficient is a constant. So we're going to get a constant, a1 e to the t. We check for any duplicated terms. There is none here. So we're done with the first one. Okay, the second one, you have a polynomial of the first degree. So you change it into, this is a1, so we get a2 plus a3t e to the -t. Okay, you check for any duplicated terms. There is nothing here. Okay, because e to the -t and the cosine are together. So it's done. It's going to be plus the third one, e to the -t sine t. The coefficient is a constant. So you have to have a combination of a sine and a cosine. So it's going to be a4 e to the -t sine t plus a5 e to the -t cosine t. Now you check it and there you are. You get the duplication over here, so we have to upgrade it. So this is how we are going to do it. Okay, so only for the third one, you get the duplicated term exactly as is into the YC. So that's why you multiply both of them, of course, by T. So that gives you the, this is going to be your YP. Any question? So that was question number 2. getting the form of the YP without solving, the actual, solving for the actual coefficients. And again, the purpose is that homogeneous one that you solve is not going to be of a second order. It's going to be higher order. And make sure that then get the repetition. Don't miss it. Okay, so this is going to be one case that we have. Any question? Now, the next part is going to be, I go with the question number 4. If I get time, I think I posted number 3 for you already. But it's not important. We come back to it. The next one is solving the equation by variation of the parameter methods. Okay, so this was undetermined coefficient. You know that there are restrictions here. The restrictions are that the coefficient must be constant, and your function on the other side, you can have only trigonometric one, exponential one, and the polynomials. So if it's going to be anything else, automatically you should do the variation of the parameter method. Okay, let's do it, then I'll give you a break. Okay, so this is number 4. Number 4, you want to solve. Okay, that's it. Solve the equation. It's a differential equation, of course, non-homogeneous. Solve the equation by variation of the parameter. Variation of, because I've done it before. That's right. Okay. It's going to be, we'll talk about it if I get time. Okay. So solve the equation by variation of parameters. Now, we have 2 here. Okay, in this case, you know what to do. We have to solve the homogeneous one again. Okay, variation of parameter is YC would be C1, Y1, C2, Y2. You change it to the U1, Y1, U2, Y2, and then you're going to find the U1 and the U2. And you got to be careful when you want to take the, when you want to integrate to get the U1 and the U2. So let's try. It's very similar, probably we did this, but we check it. Something like tangent, secant. I think on the quiz we give you secant. So these are the popular one. It's not going to be sine or cosine because it can be done by the undetermined coefficients. Okay, so this is it. Quickly, we solve the homogeneous one first because we need that solution. So y double prime plus y equal to 0. Characteristic equation is r squared plus 1. So r would be positive negative I. So we go with the I. It's a 0 plus I, alpha plus beta I. You don't have to write it, but I just remind you alpha 0, beta 1. So what's going to be YC? YC is C1 e to the 0 sine or cosine, doesn't matter. Cosine of x plus C2 e to the 0 sine. So your YC is C1 cosine of x plus C2 sine x. So that would be YC. Okay. Now, in order to get the YP, we need to use the variation of the parameter method. So we need the YP. R of x is tangent. You just check, make sure that the coefficient of y double prime is 1 when you pick the R of x. And this is true for this one. Okay. So we are fine. So we introduce the YP and you work on it. So you have to identify the y1 and y2. You take the y1 to be cosine x, y2 to be sine x, and then you take the yp to be, u1. That's it, u1 y1 plus u2 y2. Okay, that's the case. You know that you need the Wronskian to start working for the U1 and the U2. So the Wronskian is missing. the Wronskian y1, y2 prime minus y1 prime, y2. You have to find this one to get this result. Okay, so it's going to be equal to the y1 is cosine of x times it by y2 prime, which is going to be cosine of x, minus y1 prime is a negative sine x times y2, which is sine x. Okay, so that gives you cosine squared plus sine squared. 1. Nice. So the W Wronskian is equal to 1. So that should be a straightforward integral. Now we are going to find the U1 and the U2. Remember the formula for the U1? U1 is integral of negative y2 Rx divided by the Wronskian and the dx. So it's equal to the integral of negative y2. Your y2 is sine. So negative sine times tangent divided by w and the dx. Okay, you know the tangent will be sine cosine, and then be able to take care of this one. Sorry, w is 1. W is 1, so we end up with the negative sine x tangent of x dx. Okay, so one way to do it is just to change the tangent into the sine over cosine. Okay, so this is going to be negative sine square of x over, and that's a dx here. Negative sine square over cosine x dx. We have to find this integral. Any suggestion? Yes,
1 minus plus 1.
that's it. Yes, we change the sine square to the 1 minus cosine, and then we break it. So it's equal to, we may pull out the negative sign. So the top would be 1 minus cosine square of x, and that would be cosine x. Okay, we break it. It's 1 over cosine, which is secant, minus cosine. Cosine square of x over cosine x dx. So the first one would be secant. And the second one, we simplify, that give you cosine. We put the negative outside. Okay. And so we integrate. What was the integral of a cosine secant? ln absolute value of secant of x plus tangent of x. That's integral of a secant. Okay, then negative positive integral of a cosine would be just sine. Sine x. Remember, no constancy. So that give you u1. Any question? And make sure, I told you the other day, is a change of parameter. You usually use this one. Integral of a secant, ln of the absolute value of a secant x plus tangent x. Make sure you know this. Okay, that's a u1. You have to go back and find the u2. And then substitute to simplify to get the yp eventually. Okay, are you done? So we go with the u2, we get the y1. That would be easy to find. Even we may be able to do it here. So if you go with the u2, is going to be y1 r of x over the Wronskian. Going to be equal to y1. Your y1 was cosine. So that gives you cosine x. Then you have a tangent x, Wronskian of 1. Tangent is sine over cosine. So that gives you sine. So that gives you sine x dx, which is a negative cosine. So that gives you U2, negative cosine x. Okay, we go back and then we form the YP, U1. Okay, U1, Y1, U2, Y2. You have to simplify that if it's possible. Okay, so I'm going to go to the next page to finish it. So this is it. Now we are ready to give you the YP. YP, U1, Y1 plus U2, Y2. So it's going to be equal to, okay, the U1 is negative ln of the absolute value of the secant x plus tangent x. Okay, and the plus sine x. It's multiplied by y1. Y1 was cosine, yes? So that give you cosine x. Now plus U2. U2 is a negative cosine x times y2, which is sine x. To multiply, then this sine cosine will cancel out. So that give you, this is it, negative, multiply this inside, negative cosine x, ln of the absolute value of a sine x plus tangent x. It's going to be plus sine x cosine x and minus sine x cosine x. So this two would cancel out. So the final answer is YP equal to the negative cosine x. Okay, ln of the absolute value of a secant x plus tan x. That is going to be YP. So the general solution is the YC plus YP. And you are done with the variation of the parameter. Yes. Which one?
For the Y.
No, YP is one particular solution. YP is one solution, but the YC is the general solution. Okay, that's it. So we give a short break. We come back. There's one more. We check it to see, make sure that we'll be fine to find it. We are going to do variation parameter twice for us. This is once. The other one is you have to do it when we give you a Cauchy-Euler equation. So be ready for it. Okay, that's fine.
For number three, number three, the one we had scheduled, would that be Raskin?
Yeah, it's a variation of parameter.
Okay.
I take that.
What would you say is that? The power series stuff, like.
I mean, I'm saying.
And then the next thing, rearrange things, I'm thinking very different.
Oh, yeah. No, honestly, I mean,
I didn't do like trade shows for education.
Did you watch the eclipse this week?
Like whiteboard like this.
Saturday morning is 9.
So it's gonna.
Did you miss it?
Let's drop it to the center.
Ryan, there's a picture.
At least like.
Oh,
what's that?
And then we got together at Palomar and astronomy conference. Had a disc ball, sort of sparkling one.
Oh, no. You know,
With all the reflections. The planetarium. You went today, I'm part of the astronomy. And today our meeting with planetarium. Even all the shadows in the trees, they're really present. And then my,
Right there.
but they were showing.
If that was always.
That sounds good.
Because we looked at my, oh. Yeah.
Oh, that's a good idea. I should have looked at that. Oh, during the night. Was it on the weekend or during the weekday?
Did you see?
That'd be a good-
It's on here.
Today, it was me.
Oh, I wonder. Oh, no, non-linear. Non-linear.
We all went today.
Oh.
Yeah, X missing Y.
2:32 minutes. Yeah, there's a big one. That's a bunch of things other than that.
Like, I was going back to the power series.
Oh, huge.
I went to the
Well,
first
it
one
said that
in
one.
Arizona when I
Oh,
was
there's one.
fifth grade.
There's two of them.
And then they've been to. Many, but just never. finished it. But Manchester has a big one.
Yeah, that was a big one, yeah. Jordan Bank.
I went to. A lot of
That was so nice.
like the one that has the big telescope.
Talking about that, that's all it is. I know what more.
Like on the. I volunteered there, but I went to a handful of those.
Literally, we went very forever, trying to compare like, oh, it's on the I did go positive.
They have really got, this is what I got
I was gone.
into. Why? Just.
Like with Ron there.
So this one's doing something.
Oh, yeah. Oh, I hated that. I don't remember. I see it. Like the fields.
Setting it down. Like, actually.
I like that. I like
Way like that.
plus me buck, but then whatever like she.
So they want to set it.
That's the
the line. One of them up there on the line.
So I like.
Yeah, and I was like.
I like
This line.
the math, the physics, astronomy, and that.
Forward side. It's like, I get you there. Yes.
And it took me a while.
I'm on it. Like,
Yes.
the last thing is.
Yes, I will. be
No, she didn't put that on on our exam, so I don't know. Yeah, those were the ones that said. Yeah, she didn't.
Is there any assigned homework for 5.2?
Stokes are,
Yeah.
divergent down. Oh, yeah, I was like, nope.
Alright.
Oh, we did.
Thank
Is
you.
that written? Is there more like test with that? No.
Yeah, that was- they got really bad here. It never happened. Interaction.
It's pretty good, you're like, yeah.
Yeah.
Oh, yeah. It's finding like the curve.
You don't, I didn't hear the.
You'll
You're
know why.
honestly, like, if you wanna go to.
Yeah, that class was like, it wasn't difficult, it was just hard to wrap your head around what we were doing.
Yeah.
The work was like, it was del dots.
Yeah.
Curl was, del dots, yeah. Yeah. For, that's how, for Thomas, it's law. Right, yeah. For, you know, oh, he gives you like a max level of grade. Yeah, it's not, it's very long. It's not. Did you take 231 last semester? Oh, no, you already took it. Did you take, sorry?
Pretty cool.
I'm not, I don't think I. Engineering. Yeah, I'm like. Yeah, I have to do. Oh. None of this. Several majors. Yeah, take, I really like. Yeah, it's really, I'm literally like. Yeah, like, I didn't know. I didn't know where I could get by. Like get a certain good. I can't stand for. Yeah, I get. After taking the night, it's a very nice. I want to get the extreme like. Yeah, like you define what on that number is. On number.
Okay, let's do the second one. There is another one here. So we check that on true in case of the integration.
Are you?
So that would be 4B. Same question, you want to solve the equation using the variation of parameter method. So quickly checking that integral part. Okay, plus y equal to. I will post your extra one if you like for this test later on. Maybe tomorrow. It would be extra 2. That would be good for you, you know, to get practice. And you submit it for the extra points. Just make sure to do it. And there you are. Again, you see, you have to use variation of parameters because this function is not the type that you'll be able to do it by the undetermined coefficient.
What is the?
Y double prime plus 2y prime plus y equal to the e to the negative x over x. And we assume that x is positive. Okay, so for the, go for the characteristic homogeneous equation. So this is it. Characteristic equation would be 2r plus 1 equal to the 0. It's a perfect square. It's r plus 1 times r plus 1 equal to the 0. So we get the repeated solution. R equal to -1 and -1. Okay, so your YC is going to be equal to a C1 e to the negative x is the first one. Since it's repeated, so C2x e to the negative x is going to be the second solution. Okay, so that would be the homogeneous one. Okay, you want to find the YP with the method of the variation of the parameter. Okay, so there you are. A YP is missing. You have to introduce your Y1, Y2. So we take the Y1 to be equal to the e to the negative x, Y2 to be equal to the x e to the negative x, Rx. Rx is e to the negative x over x. We check to make sure that the coefficient of the y double prime is 1. It is 1. So nothing to worry about. So by the method of the variation of the parameter, this would be u1 y1 plus u2 y2. Okay, so we have to find the Wronskian first. So the Wronskian of y1 y2 is y1 y2 prime minus y1 prime y2. Substitute. You have the y1 e to the negative x, the other one x e to the negative x. So it's equal to the e to the negative x for the y1. Y2 prime, have to use the product rule. If of the first time second would be e to the negative x. Second first, x e to the negative x. Lift of the second one is negative e to the negative x times the first one. Okay, now it's going to be minus y1 prime. Y1 prime would be negative e to the negative x times the y2, which is x e to the negative x. Okay, distributed, simplify it. So it's going to be multiplied, go forward. That give you e to the negative 2x minus x e to the negative 2x. When you multiply, you know that we add the exponents. Negative would be positive, so that go plus. And that would be x e to the negative 2x. Okay, now these two would cancel out. So the Wronskian W is e to the negative 2x, which is nice. It's a non-zero, so this means you're set to go. Okay, your R of x is a nice function, so we just forming the u1 and the u2. Okay, let's find out u1 first. u1 is integral of negative y2 rx over the w dx is equal to y2. So your y2 is x e to the negative x. So it's going to be negative x e to the negative x times that by rx. So r of x is times that by e to the negative x divided by x. And the Wronskian of e to the negative 2x. Okay, that's e to the negative 2x. So we simplified the x and x would cancel out. On the top, we get e to the negative x times e to the negative x, which is going to be negative e to the negative 2x. And the bottom one is e to the negative 2x. So it cancels out. We get negative dx, which is negative x. So u1 is negative x. Okay, I just substitute the y2 to get these. Any question? So that's u1. You go back and find the u2. Just writing down. When you're done, we go and find the u2. So these integrals happen to be nice. Check your practice quiz. Remember, we did have 6 problems. I'll give you the solution of all of them. And they were nice integrals when you get it finished. Yeah, that's it, you know, it's the possibilities. Okay, let's get the, are you done? That's U1. So similar one, we go for the U2 to get it. Okay, so this is it. The formula for the U2 is integral of the Y1 now. R of X over the Wronskian. Okay, so your y1 was e to the negative x. So that give e to the negative x. R is e to the negative x over x. And the Wronskian of e to the negative 2x dx. Now again, the top e to the negative 2x, e to the negative x, e to the negative x would be, you see, it's going to be like e to the negative 2x over x, and that's e to the negative 2x dx. Now e to the negative 2x will cancel out. You get 1 over x. It's the integral of 1 over x dx, which is ln x. X is positive, so we don't need to get the absolute value. So u2 would be ln x. Okay, now we have the u1 and the u2 all together. If it's possible, you simplify it. Otherwise, you declare the solution. Okay, there you are. So yp is u1 y1 plus u2 y2. It's going to be equal to the u1 is a negative x. Y1 is e to the negative x, I think. Let's see. Let's check this one. Yes. Okay, so it's going to be negative x times e to the negative x plus u2 is ln x times y2, which is x e to the negative x. So if you simplify it a little bit, so that gives negative x e to the negative x. And this would be simply plus x e to the negative x ln x. So that would be your particular solution. So the general solution is yc plus yp. And you're done. Okay, so this is a method of the variation of the property. One for the test. Yes.
You cannot into negative x, either the negative x, because it's attached to ln x.
Yes. Yes, because the two different terms. You can factor it out, but you don't need it. Okay, that's fine. Okay, so this is question number 4. Any question? No, question number 5, Euler equation. Okay, Cauchy-Euler equation. We give you one. Remember, this is the one that is very similar to the equation with the constant coefficients. But the solution is going to be, with the constant coefficient, the solution would be of the type of e to the rx, and this is going to be x to the r. So we give you one of these, but we have 2 here, homogeneous, and then non-homogeneous. We give you right away one non-homogeneous one. Okay, solve, this is it, solve each Euler equation. So they give you the hint that it's Euler equation. So you know the method. Part 1, it is homogeneous. So you have x squared y double prime minus 4x y prime plus 6y equal to the 0. Remember, Euler start with x squared. You see x squared y double prime. The powers and the order are the same. The next one is going to be x to the first power, first derivative. And the last one is x to the 0 power, and the 0 derivative. Okay, so to solve this equation, we give you a formula, or my suggestion was just check. We force the equation to be of the form of x to the r, remember? So the solution is going to be, you let y equal to the x to the r, differentiate it, that give you r x to the r minus 1, differentiate it again, so that give you r minus 1 x to the r minus 2. Unless you memorize that formula that we proved it for you. Go back, substitute into the equation, you change it to the characteristic equation in terms of the r, find the r, and come back and declare the solution. Okay, substitute here. So it's going to be x squared y double prime r minus 1 x to the r minus 2 minus 4x y prime. r x to the r minus 1 plus 6 okay y x to the r equal to this. Remember, all of them would be x to the r, so we can drop the x's. So the leftover is r times r minus 1 minus 4r plus 6 equal to this. Okay, multiply it, r squared minus r minus 4r plus 6. So it's going to be r squared minus 5r plus 6 equal to this. Solve this equation. Two numbers. Numbers is going to be -3 and -2. So we have two distinct solutions. R1 equal to the 3 and R2 equal to 2. Remember, each solution gives you x to the r. So the YC would be C1 x cubed plus C2 x squared. That is, it was just your equation is homogeneous, so it's a y instead of the YC. Okay, remember, if you have a repeated solution, you get x to the r and x to the r ln x. If you have a complex solution, you must make sure you know that one, that you see we get e to the x cosine of the ln of the beta ln x. Yes. If you have Euler equation mostly is going to be if it's going to be the case. But the Euler equation most of the time is a second order. So you may get only one repeated solution for that. Okay, it's fine. But everything would be like the one that you did before. So just your solutions are different. Instead of e to the rx, you have x to the r. You can multiply, go forward. Okay, so that was the warm-up, if you like, for the homogeneous. But the big one is going to be a non-homogeneous Euler equation. And expect one of those. So that would be part B. Okay, so that's a 5B. This would be a nice problem because you have to use the variation of the parameter method to find the YP. This is the only method that you can do. Okay, so we want to solve this equation. The equation is x squared y double prime minus 2x y prime, okay, plus 2y equal to, not equal to 0, is equal to the x cubed ln x. Okay, so it's a non-homogeneous Euler equation of the second order. So as usual, you know that you have to solve the homogeneous one first, find the YC, then find the R of X and use the variation of parameter method to find the YP. Okay, so go with the homogeneous one first. Solution. We are going to solve. Okay, solve this equation first. X squared y double prime minus 2xy prime plus 2y equal to 0. Okay, again, suggested solution is x to the r, differentiate it, r x to the r minus 1, differentiate again, r minus 1, x to the r minus 2. Okay. Yes.
We need to skip the first step and then you wrote the next step, but equal to 0. Would that be okay? Or would you?
Yes, why not? Okay, that's one. I am teaching, so I have to write. Otherwise, I do it right away myself.
What?
I am teaching. If I want to do it myself, I just put it in equals 0 right away.
Oh.
Okay, that's fine. Yeah, you can do it. Or you can memorize that formula, substitute it. Okay, are you ready? Substitute. What's going to be the result? X squared r times r minus 1 x to the r minus 2 minus 2x r x to the r minus 1 plus 2x to the r equal to 0. Drop all the x's. So this is it, because all of them would be x to the r, and we divide by x to the r, remember? So what's the leftover? R minus 1 minus 2r plus 2 equal to the 0. Simplify, so for r squared minus r minus 2r plus 2 equal to the 0. Combine the like terms. 3r plus 2 equal to the 0. Nice numbers. Two numbers, product of 2 and the sum of 3. So r minus 2 times r minus 1 equal to the 0. Didn't get the repeated solution here. Okay, so we have two solutions. R1 equal to 2 and the R2 equal to 1. Okay, so what's going to be now YC? YC is going to be C1 x squared plus C2x. So this is going to be YC. Okay, but the equation was non-homogeneous one, so we have to find the YP. Now you have to be careful. We are going to find the YP. The only method is variation of the parameter. So we have to identify the Y1. So the Y1 is x squared, Y2 is x, and this is the place that you got to be careful. R of x. What is R of x for this?
No.
Over X, ln.
That's it. X cube ln x, make sure divide by x squared. That's it. So, because the Euler equation always starts with the x squared. Your formula must be, okay, normalized. So there you are. We get x cubed. I write it down so you know what's going on. Divided by x squared. The coefficient of the y double prime in the formula of the variation of the parameter must be 1. So that's why you divide it by x squared, okay? So the result would be x ln x. If the integral getting complicated, probably you miss this line, because there is no other way that you miss something. So we have to go with the Wronskian first, because we want to use it. You know that this is your YP is going to be, suggestion is U1 Y1 plus U2 Y2. So we have to check the Wronskian first. So what's going to be the Wronskian? Y1 Y2 prime minus Y1 prime Y2. Substitute. So the Y1 is x squared. Y2 prime. Y2 is x. Y2 prime would be 1 minus Y1 prime, derivative of x squared 2x times Y2, which is x. Okay, so the first one would be x squared minus 2x squared. The result is a negative x squared. Remember, x is positive because of the ln x. So we have nothing to worry about, because the Wronskian must be a non-zero number. So the Wronskian is negative x squared. Okay, any question? So go for the U1. Variation parameter, formula for the U1. So it's going to be U1 equal to the integral of negative Y2 R of x over the Wronskian dx, substitute. So it's going to be negative Y2. What is Y2? Y2 is x, so negative x. R of x. R of x is x ln x. X ln x. Wronskian of a negative x squared. You simplify it. The top would be negative x squared ln x divided by negative x squared dx. I missed the dx here too. Okay, negative x squared and x squared cancel out. You end up with integral of ln x dx. How are we going to find this one? How are we going to find it?
UV minus interval dV.
That's it, integration by parts. Okay, integration by parts to get this one. And remember, this is it, u would be ln x, and the dv would be the tx. So that would be du, which is 1 over x dx, and this would be x. So if you put them together, uv would be x ln x minus integral of v du, v du. V is x, du is 1 over x dx. So this would cancel out. You get x ln x minus integral of a dx, which is x ln x minus x. So this would be your u1. So the u1 ln x minus x. We'll be prepared for, because it's going to be ln x. Yes.
Would you like us to write out that number, or is it okay if we don't?
That's the question. Yeah, ln x is popular. We accept x ln x dx. Okay, so this is going to be the case. Any question? So that's the u1. We have to check the u2 to see what's going to be the term for that one. It's very popular for the Euler equation. So yes, we accept it. So that is u1. Ready? Let's see what's going to be u2. For the u2, u2 would be y1. Okay, y1 out of x over the Wronskian. So what is the y1? Y1 was x cubed, yes? X squared. Okay, y1 is x squared. Okay, R of x is x ln x again. And the bottom one is negative x squared dx. Now these two will cancel out. Now you have to do this one. We get integral of, you get negative integral of x ln x dx. So, similar one for the by part. For this one, again, u would be ln x. Okay, and the dv would be dx. So the du would be 1 over x dx, and the v would be x. So if we put them together this time, it's going to be x ln x dx is uv x ln x. I missed something, yes? I made a mistake, sorry. This is dv is x dx. So that would be x squared over 2. That's it. Okay, so u is ln x, dv is x dx. X dx. So v would be x squared over 2. So we have more to go. Now we have x squared over 2 times 1 over x dx. You simplify it. So that gives x ln x minus integral of, one of the x would cancel out. You get 1/2 of x dx again here. And you integrate it, x ln x minus, it's going to be x squared over 2. You already got the 1/2, so 1/4 of x squared. So that would be your u2. u2 is going to be x ln x. You should have, that's it, yeah. Okay, uv, sorry. That's x squared over 2, x squared over 2, x squared over 2. Now that makes sense. It's x squared over 2 ln x minus x squared over 4. This would be the final answer. You know that there is one formula for this one too. And that is the one. You got the x is going to be x squared over 2 ln x minus x squared over, you squared the 2. That give you 4. So that would be, yes.
The first term would be negative and the second term would be positive. You had a negative.
Okay. We have a negative sign. Now I'm applying that negative sign here. Negative 1+. Yeah, it was a negative integral of a. Okay, negative integral of x ln x dx. Okay, so we have to go back and put them together to get the yp. If it's possible, we simplify it. So there you are. Yp equal to the u1 y1 plus u2 y2. Okay. So we did the u1. What was the u1? It's x ln x minus x. Okay, that's x ln x minus x times the y1, which is x squared, plus u2, which is this one, negative x squared over 2 ln x minus x squared plus. Okay, and that would be multiplied by, okay, multiplied by y2. What is the y2? Y2 is x. That is x. Even if you multiply it, you won't be able, probably there is a simplification only over here. So distribute it. It's going to be x cubed ln x minus x cubed. And that would be minus x cubed over 2 ln x. And that would be x cubed over 4. Okay, you get a core there, and we get a -1 over here. You subtract it, that give you 3/4. So yp would be x cubed ln x. Okay, these two. And that give you minus 3/4 of x cubed minus x cubed over 2. I could have done the same for this one. Okay. So that's a 1 minus 1/2, which is going to be 1/2 again. So this would be the final part. Okay, I just simplify the like terms. X cubed ln x over here, x cubed over 2 ln x is like 1 minus 1/2. 1 minus 1/2 would be 1/2. And we have these two the same, is a -1 plus quarter. -1 plus quarter would be 3/4. So this would be your yp. So the final answer, as usual, y is equal to yc plus yp. Okay, so that would be Cauchy-Euler equation. So we give you one, it's going to be non-homogeneous one, and be prepared for it. If you want to bring any formula, just bring them in. Okay, to get this, because they're going to be quite a lot to get this true. Okay, that's question number 5. Any question? So what we did, they were all linear. So how about a non-linear differential equation? Remember, we can solve 2 types of the non-linear differential equation. The one that the y is missing, or the one that x is missing. So there's 2 types, we give you one from each. Okay, we try to give you something short, but they're not difficult. You will end up with something like separable, Bernoulli, or linear equation to solve. Okay, so let's try. See what we have over here. It's a number 6. You get quite a lot to practice. So solve each equation. Of course, they are non-linear equation. Solve each, just for information, non-linear equation. Okay, so there you are, the first one, part 1. Part 1, you have y double prime plus y prime all squared equal to the z. That's the one. You see, in this case, x is missing. So that's a type 2. The type 2 takes a little bit more to do it, okay, because we have to change the derivative. So you recognize, you have to identify which one is it, type 1 or type 2, because your substitution will be different. So in this case, the variable x is missing. So remember, your substitution would be what? You get the u equal to the y prime, then y double prime. Remember, it's going to be u du dy. Since the x is missing, we have to change the derivative with respect to the y. We'll be able to have the y versus v versus u versus y. To be able to do it. That's why we change it. Okay, go back to the equation, substitute to see what's going to be the leftovers. So this is it. We go to the equation. I just remind you that I'm going to use this equation. Okay, y double prime. It's going to be y u du dy plus y prime squared u squared equal to this. That's the result of the equation. It's easy to solve. Any suggestion? How can I solve it? First thing to do, you can divide by u. It's a u and the u is squared. Okay, you assume that the u is not 0. So you divide by u, so that give a y du dy plus u equal to the 0. Now separate. You know that if u happen to be 0, y prime is 0, y is constant. Okay, so that's why we can do this. So that's it, separated variable, okay, or separable. Remove the u to the other side. Cross multiply to put them together. If you like, this is what would happen. So to get the y and the dy, so y over, okay, dy. And over here, we get the negative u over du. You see, if you cross multiply, you get exactly what you have here. So now it's a separable variable. Take the integral. Oh, I'm sorry, I can't do it. I have to switch it. I write it down badly. So I just flip them. So it's going to be dy over y. And this is going to be du over u. Okay? Because you want to differentiate it. You want to integrate it. Okay? It's the same thing. Now we can integrate dy over y equal to the integral of du over u. You know that both of them would be ln x or ln. This is going to be ln y. And this would be minus ln u. Somewhere you have to put your constant, okay? You can call your constant C1, or if you like, you can call it ln of C1. Okay, it doesn't matter to get to the other part. That make it easier for you to be able to handle the rest. Okay, or you can leave it as is. It doesn't matter. But because you know that you have to find the u and then change the u into the, okay, change the u into the y prime to be able to do it. Different way to do it. You can stay with the e if you like, you know, this is various options that you have. If you want to solve for y as is, you see y would be, okay, it's going to be e to the, you see, e to the negative ln u plus c1. So you break it into the e to the ln of 1 over u times the e to the c1, if you like. So now that give you y equal to the 1 over u. You can call this one c1 again, it doesn't matter. So we get this one. So y would be c1, okay, c1 over u again. It's one way to do it. Okay, any question? Different way to simplify it. Now, this is it. ln y. Then you have to change the u into the y prime and continue. Yes.
If we left it as, like, 1 over u plus, or 1 over u times
Yeah, but remember, you have to continue. And not done. You have to change the u into the, okay, change the u into the y prime to get these numbers. Different way today, you see? One suggestion is this one. Look at this one. It's ln y equal to the negative ln u, for example. Okay, you can call this C1 ln of C1. You see? So that give you ln of y equal to ln of C1 over u. It's using this idea of the quotient rule in, or the product rule in case of the ln. Then you drop the ln, so y would be C1u. Okay, same thing. Okay, that's it, but we are not done. You have to substitute for u. So you better change it. You see, u is equal to the y prime. So y would be equal to the C1 y prime. Okay, cross multiply and then change it. So that give you y prime equal to the C1. Change the y prime into the dy dx and then integrate eventually to get your y. Okay, so it's going to be y dy dx equal to the C1. Yes? What's that? No, I just want to show this one. I just continue here. Okay. So it's going to be simply y dy equal to the C1 dx. Now integrate once more to get your final answer. So if you're integrating y dy equal to the integral of C1 dx, so that give you y squared over 2 equal to the C1x plus C2. So we can multiply by 2 if you like. So the final answer is y squared equal to the, again, really, C1x plus C2. So that gives you the solution of the equation. When you write it down. No. If this wants to take the square root, you have to have more information. So we write it down and see if we can find it. Yes, what's the question?
You get L, but the very top ln y equals negative ln equals ln C1.
I said that you can change the C1 into the ln of C1. It's a constant. That will help you to be able to continue.
Okay, but why is it negative ln u?
Because it is given to you over here. You see this one? I said you can take it from here and go in this. Depends on what type of function you do.
So can you take it from,
You will go from here. You don't like that, you go from
and you just integrate both
Yeah.
sides, right?
Just show that one of them are the same. You do this type of things, you may call a constant tangent of C. That will help you to be able, because you have to integrate it. Get these numbers. Okay, so let's check another one. That was a type 1. A type 2.
I thought that one was type 2.
That's a type 2, yes. You have to get the one type 1. Okay. So let's get one of those type 1. Some of them it takes time, but most of them can be done easily. So let's check the part B. Part B. Part B is x y double prime equal to the y prime. I don't know whether we did this one before or not, but just check it. You see the variable y is missing. So that's a type 1. Is more familiar and use the type 1. Okay, solution. The variable y is missing. So substitution would be what? U would be y prime. U prime would be y double prime. Because you already got the x there. So we don't have to change it to the, okay, the new format. Go back, substitute. What's going to be the result? X y double prime, x u prime equal to y prime u. Y prime cubed is going to be u cubed. Okay, and that is going to be the case. So again, a different way to solve this one. So we change the u prime into the du dx. And that would be u plus, let me see. Different way to do it. Any suggestion for this one? If you do the separation, I did this one the other night, you'll be in trouble. Okay? Because you see, this is the one. So if you want to separate it, what would be the result? X du is u plus u cubed dx. So what we have now is going to be du over u plus u cubed, and that would be dx over x. Okay, you've been troubled for this one. Because remember, when you find the u, then you have to substitute to get the u prime. So that would be very, okay, not a good method. That's one. Because you have to do the partial fraction. And this is u times 1 plus u squared. So, you know, it can be done. It can be done. But the way I did it the other night is I save it to u prime and I change it to the Bernoulli equation. I think that was the one. So that would be easier, you know, to take care of it. But you can try this one for yourself if you like.
Nah.
Okay, but this is the way I did it the other night. X u prime. I did some of them when we talk about it. You see over here. So I like it to change it into the kind of a linear equation. So what I do is I have the x u prime. So I need the u. This is u. I don't need the u cubed. Remember, for the linear equation, you need the y prime and the y. So divided by x, u prime minus 1 over x u, and that would be 1 over x u cubed. That's a Bernoulli equation now. It's a Bernoulli equation in terms of the u and the x. Okay, so that would be Bernoulli equation. So you have to get rid of the u here. U behave like the y that we did have before. So you divide by u cubed, so that gives you u prime, u to the negative 3, minus 1 over x, u to the negative 3, equal to the 1 over x. Okay, so it's going to be u prime, u to the negative 3, minus 1 over x, u to the negative 2, equal to the 1 over x. Remember the substitution, the z that we have. So you take the z to be equal to the u to the negative 2, and then you find the z prime. Negative 2u to the negative 3 u prime. And you are going to find what is u to the negative 3 u prime, which is going to be negative z prime over 2. The procedure of the, okay, of the Bernoulli equation. Okay. So go back, substitute would be an equation in terms of the z that can be solved easily. Okay, so I'm going to substitute here. What's going to be the equation now? This would be negative z prime over 2 minus 1 over x z, okay, equal to the 1 over x. To solve it, you multiply by negative 2, and then you go for the integrating factor of the linear equation. So that gives you z prime plus 2 over x z equal to the negative 2 over x. Now this is a linear equation with p of x equal to the 2 over x and the q of x equal to the negative 2 over x. Integrating factor, so integral of a px dx would be integral of a 2x over dx. That give you 2 ln x or ln of x squared. So your integrating factor mu would be e to the integral of a px dx, which is e to the ln of x squared, which is equal to the x squared. Okay, that's integrating factor for the z. So this is going to be z. Z is equal to 1 over mu. Remember, 1 over x squared. Integral of mu times qx. Mu is x squared. Okay, negative 2x is q. So this is going to be 1 over x squared. Integral of, this two would simplify. So that gives me negative 2x. Negative 2x dx. Integral of negative 2x would be negative x squared. So it's equal to the 1 over x squared times the negative x squared plus the constant c1. So that gives you z. So z is negative x squared plus c1 over x squared. You keep it, and then you, if you need it, then you simplify it. But remember, z is u to the negative 2. Z is u to the negative 2, so bring it here and then solve for u. And then you go back and substitute the y prime and you get the result. Okay, any question? I'm going to go to the next page to substitute for z. Z is u to the, okay, u to the negative 2 to be able to take care of this one. Are you done? So I switch to the u to the negative 2. Then I can find it. So this is it. Z is u to the negative 2. So now it is going to be equal to whatever you have over here, negative x squared plus c1 over x squared. That's u to the negative 2. So you change it to the u squared, and then you find it. C1 over u squared is going to be, okay, this is what we have, negative x squared plus c1 over x squared. So flip it, u squared would be x squared over negative x squared plus c1. You take the square root to take the u. So if you take the square root, the top would be, you see the square root of the x squared over negative x squared plus c1. So your u would be, the top would be x, the bottom one would be c1 minus x squared. So that's your u. But you're not done because u is y prime. You replace the u by y prime and then you find the bar. Okay, u is y prime. So y prime is equal to the x, the square root of a c1 minus x squared. You change the y prime into the dy dx and you integrate it. So dy dx. Okay, you can bring this one up because you have to use the substitution in order to integrate it. Okay, cross multiply. So that gives x times c1 minus x squared to the negative 1/2 times the dx. Integrate. Integral of the dy is the x times c1 minus x squared to the negative 1/2 dx. So that would be y. This one, u sub. If we take the inside to be u prime would be negative 2x. You already got the x, so I need a negative 2. So this is the way I do it. It's a negative 1/2. You can use your u substitution if you don't like this method. Okay, that's it. This is u. And the rest is du. So y would be negative 1/2. C1 minus x squared to the half divided by half and the C2. 1/2 and 1/2 will cancel out. So eventually y would be negative a square root of C1 minus x squared plus C2. Okay, it's kind of a most general one that you can have for the tribe y.